Now let us solve question 2. Question 2 A. Find the rank of the matrix A equal to, so you are given matrix like this: 1, -2, -1, 3, 2, -4, 1, 0, 1, -2, 2, -3. And you have 2 marks up. Now here we need to convert this matrix into row echelon form. So here we are having reading 1. We should make these two entry to be 0. So we do the operations, elementary row operations in R2, R2 minus 2R1, because 2 is here, 1 is here. And in R3, it is R3 minus R1, because 1 and 1 is here, so just subtract. And so we have this R1 no change, 1 minus 2 minus 1, 3. Now here multiply with -2 and add, so -2 plus 2, 0. Multiply -2 here, so that will be 4, and -4 here, so it is 0. Multiply with -2 here, and -1 is there, so that is 2, and +1 here, so that is 3. Then multiply with -2, so that will be -6, and add with 0, so that is -6. Now this is just subtract R3 minus R1, so 1 minus 1, 0. -2 minus 2, so subtraction, so it is 0. 2 minus -1, so that is nothing but 3. And -3 minus 3, this is -3 here, and R3 minus R1, so -3 minus 3, so -6. Now here you can see that the second row and third row same, so let us make the third row to be 0, like uh, R3 minus R2. So you'll have 1 -2 -1, 3, 0 0, 3 minus 6, this is 0 0 0 0. And finally you can just divide by this 3, so R2 into 1 by 3, so that you have 1 minus 2 minus 1, 3, this is 0 0 1 minus 2 is 0 0 0 0. Now which is in row echelon form. And so the rank of a matrix is the number of non-zero rows, and the number of non-zero rows are one here and another here, so that is nothing but 2. Next question. So next is like this: solve the system of linear equations using Gauss elimination method. and here you are having 3 marks. The system of equation you are given is like this: 2x plus 2y plus z equal to 1 minus 2x plus 5y plus 2z equal to 1, 8x plus y plus 4z equal to minus 1. So let us first make the augmented matrix. So here augmented matrix like this is equal to, this is 2 2 1 1 minus 2 5 2 1 8 1 4 and minus 1. Now here there are options, but you can do like this. Say here 2 is there, we need 1 here, but here 2 is there, but below you can see that all the entries are multiple of 2. So there are two options: either you can make it 1 here just by dividing by 2 and then make all the entry below to it to be 0, or first you make 0 here, these two entry by using these two, and later on you make these two as 1. So whatever makes it easy, you can do that part. Okay, so let us make it 1 and then make it 0, the entry below to it. So let us do like this: r1 r1 into 1 by 2. I'm doing this because just the reason is the computer IT students should write the program, and your program will do the systematic work. So for that you need to make it 1 here. Otherwise, as a human mind, we can do like this: make it 0 here, make it 0 here, and then after make it 1. Okay. So then you have, this is 1, this is 1, this is 1 by 2, and this is 1 by 2. Minus 2, 5, 2, 1, 8, 1, 4, and minus 1. Now by using this one, you can make these two entry to be 0. So R2 plus 2 times R1, and R3 plus minus 8 times R1. So if minus 8 multiply and add here, so that will be 0. So now here we have fractions, so we need to take care. So let us do that. So first row remain as it is: 1, 1, 1 by 2, 1 by 2. Now we are multiplying with 2 first row and then add. So 2 minus 2, 0. This is 2 and 5. So that will be 7. 1 by 2 multiply 2. So that is 1 and 2 here. So that is 3. 1 by 2 multiply 2. So that is 1 and 1 here. So that is 2. Now minus 8 multiply first row and add in the third row. Minus 8 plus 8. So that is 0. Here also minus 8 plus 1, minus 8 plus 1, so that is minus 7. Now multiply here minus 8, so that will be minus 4 plus 4, so that is 0. Multiply minus 8, so minus 4 minus 1, so that is minus 5. Now the next step is So here we have leading 1. Next step here, make it 1 here. So R2 divided by 7. And so we have 1, 1, 1 by 2, 1 by 2, 0, 1. This is 3 by 7. This is 2 by 7, 0, minus 7, 0, and minus 5. So now we have reading 1 here. We are using Gauss elimination method. So make the entry below to it to be 0. So R3. R3 plus 7 times R2. So then we have 1, 1, 1 by 2, 1 by 2. Second row same 0, 1, 3 by 7, 2 by 7. Now this is 0. Now here multiply with 7. So 7 minus 7. So that is 0. Now multiply with 7. So we'll get 7, 7 cancel. So you have 3. And add with 0. So that is 3. Multiply with 7. So that is 2. And minus 5. So that is minus 3. And now here just divide by 3. So R3 into 1 by 3. So you have 1, 1, 1 by 2, 1 by 2, 0, 1, 3 by 7, 2 by 7, 0, 0, 1, and minus 1. So now you can see that this matrix is in row echelon form. So which is in row echelon form. Now let us check the rank of this augmented matrix, then rank of A. Just hide the last column, then you will have the rank of A. But you can see that first non-zero, second also non-zero, third also non-zero. These two entries are there. And so rank of AB is 3, rank of A is also 3. And how many variables are there? X, Y, and Z. So variables are also 3. So rank of AB, rank of A equal to 3 equal to number of variables. And therefore, the given system has unique solution. The given system has unique solution. Now from the third row. So from third row, you can see that this is Z and this is minus 1. So Z equal to minus 1. From second row. So now from this second row. What is second row? 1. That means Y. This is 3 by 7. So plus 3 by 7 Z and equal to 2 by 7. Equal to 2 by 7. So now you can just keep the value of Z. So substitute the value of Z here. So you substitute the value of Z. So therefore Y and Z is minus 1. So that is minus 3 by 7 equal to 2 by 7. So Y equal to 2 by 7 plus 3 by 7. So is equal to 5 by 7. So Y equal to 5 by 7. Now from the first row here. So from the first row. So what do we have from first row? X, Y, 1 by 2 Z. X plus Y plus 1 by 2 Z, and that is equal to 1 by 2. Now keep the value of Z and Y. Substitute the value of Z and Y. X, what is Y? 5 by 7. And what is Z? Minus 1. So you have a minus 1 by 2 because Z is minus and is equal to 1 by 2. So X is equal to, you take 1 by 2 on this side, 5 by 7 also on this side. 1 by 2 plus 1 by 2 minus 5 by 7. So it is 1 minus 5 by 7, and so it is 2 by 7. So X is equal to 2 by 7. So this is the unique solution. So therefore solution is X is equal to 2 by 7, Y is equal to 5 by 7, and Z equal to minus 1. Fine. Next, C. Question is, find the inverse by using Gauss-Jordan elimination method. So we need to find out the inverse of A, that is 3, 2, 6, 1, 1, 2, 2, 2, 5, and the marks 3. So let us find out the inverse. So you can start doing like this. Start from A and adjoint with the matrix identity. No need to check the determinant of A is 0 or non-zero. If it is not invertible, then during the process you will get one row to be 0. If it is not 0, any row is not 0, then you will get the inverse. So like this: 3, 2, 6, 1, 1, 2, 2, 2, 5. And this is identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1. So we need to take the procedure elementary row operation such that here you will get the identity matrix, and whatever here we are getting, that is nothing but the A inverse if it is exist. If it is not exist, then during the process here you will get one row to be 0. Okay, so now let us convert into the reduced row echelon form. Now see, here you have 1, so let us interchange these two rows. So let us do R12. So then you will have 1, 1, 2, 0, 1, 0. Then 3, 2, 6, 1, 0, 0, 2, 2, 5, 0, 0, 1. Now we have 1 here. So we can make the entry these two to be 0. So R2 plus minus 3 times R1 and R3 plus minus 2 times R1. So here we multiply with minus 3 and add all this entry. So what do we have? First row is same, 1, 1, 2, 0, 1, 0. Now minus 3 plus 3, so that is 0. Now here minus 3 plus 2, so it is minus 1. Here minus 6 plus 6, so that is 0. Here 0, so this is 1. Minus 3 here, so and plus 0, so that is minus 3. and here both 0 0, so that is 0. Now third row, multiply with minus 2 plus 2 0, minus 2 plus 2 is also 0, then this is minus 4 plus 5, so that is 1, this is 0, this is minus 2 plus 0, so that is minus 2, this is 0 into minus 2, so 0 plus 1, so that is nothing but 1. Next is we can make this entry to be 1. So R2 multiply minus 1. So we have 1, 1, 2, 0, 1, 0. Now this is 0, 1, 0, negative multiply, minus 1, 3 and 0. This is 0, 0, 1, 0, minus 2, 1. Now by using 1, make the entry above and below to be 0. Below is already 0, so make this entry to be 0. So R1 minus R2. So that 1, this is minus 1 plus 1, so 0. This is 2 because 0 is there. Multiply minus 1 with R2, so minus minus plus 1, so here 1. Multiply minus 1, so minus 3 plus 1, minus 2, and this is 0. This is 0, 1, 0, minus 1, 3, 0, 0, 0, 1, 0, minus 2, 1. Now here also 1, make all the entry above to be 0, here already 0, so make this one is only 0. So R1 minus 2 times R3, and that is equal to 1, this is 0, minus 2 plus 2, so that is 0. Here 0, so it will be 1. Now multiply with minus 2, so 4 and minus 2, so that is 2. Multiply with minus 2 plus 0, so that is minus 2. This is 0, 1, 0, minus 1, 3, 0. This is 0, 0, 1, 0, minus 2, 1. So now here you can see that this is I, and whatever here you are having is nothing but the A inverse. So you can say that which is in reduced row echelon form. And therefore A inverse is equal to 1, 2, minus 2, minus 1, 3, 0, 0, minus 2, 1. Fine. There is also in one or, and it is like this, using inversion method, solve the system of linear equation. And it is like this: x1 plus 2x2 plus 3x3 equal to 5, 2x1 plus 5x2 plus 3x3 equal to 3, x1 plus 8x3 equal to 7. Now we know that we can convert these equations into matrix form like this: Ax is equal to b, and therefore we find x, that is our solution, is nothing but A inverse b. So first we need to find out A inverse of this coefficient matrix. So what is A here? A is 1, 2, 3, then 2, 5, 3, 1, 0, 8. So first we need to find out A inverse. So let us first find A inverse. So we know the method now. So let us begin with A, adjoining with the identity matrix. 1, 2, 3, 1, 0, 0, 2, 5, 3, 0, 1, 0, 1, 0, 8, 0, 0, 1. So now here we have 1, make this 20 to be 0. So R2 plus minus 2 times R1, minus 2 multiply and 2 add, so that is 0. And R3 minus R1. So then we have 1, 2, 3, 1, 0, 0. Now here we have minus 2 plus 2, so 0. Then minus 2 multiply, so 4, minus 4 plus 5, so that is 1. Minus 2 multiply, so minus 6 plus 3, minus 3. Here minus 2 multiply, so that is minus 2, 0, 1, 0, 0, so 0. Now here 1 minus 1, 0, 0 minus 2, minus 2, 8 minus 3, 5, 0 minus 1, minus 1, 0, 0, and 1 minus 0 is 1. So now here you are having, see, fortunately 1 also. So make the entry above and below to be 0. So R1 plus minus 2 times R2, and R3 plus 2 times R2, because 2 minus 2 0, minus 2 plus 2 0. And see, so this is a 1, 0 means 1 here. Now this is minus 2 plus 2, so that is 0. This is minus 3 and minus 2, so 6 and 3, so that is 9. Multiply with minus 2, so that is 4, and plus 1, so that is 5. Multiply with minus 2, so minus 2 here, and 0, 0, so 0. This is 0, 1, minus 3, minus 2, 1, 0. This is 0. Multiply with 2 here and add with minus 2, so 0. This is minus 6 plus 5, so minus 1. Multiply with 2, minus 4 minus 1, minus 5. Multiply with 2 here, so 2, 0 and 1, so that is 1. Now here you can see minus 1, so make it 1 here. So R3 multiply minus 1. And so this is 1, 0, 9, 5 minus 2, 0, 0, 1 minus 3, minus 2, 1, 0. This is 0, 0, 1, 5, minus 2, minus 1. Now here we have 1, so make this true entry to be 0. So R1 plus minus 9 times R3, R2 plus 3 times R3, 3 minus 3, 0, minus 9 plus 9. So let us see. This is 0 and 1, so 1, 0 and 0, 0, minus 9 plus 9, 0. Now here minus 9 multiply 5, so minus 45 plus 5, so minus 40. This is minus 9 into minus 2, so it is 18, minus 2, so that is 16. This is minus 9 into minus 1, so plus 9 and 0, so that is 9. This is 0, then 1. Now multiply with 3. 3 minus 3, so that is 0. Multiply with 3, so 15 minus 2, so that is 13. Multiply with 3 here, so minus 6 plus 1, minus 5. Multiply with 3, minus 3 here, so 0, 0, 1, 5 minus 2 minus 1. So which is in reduced row echelon form. So this is identity matrix, and so this is A inverse. Okay, so A inverse is equal to minus 40, then 16, then 9, then 13, minus 5, minus 3, 5, minus 2, minus 1. Now what is the solution? Solution X is equal to A inverse B. And what is X here? X1, X2, X3. What is A inverse? Minus 40, 16, 9, 13, minus 5, minus 3, 5, minus 2, minus 1. And now what is B? So here you can see that B is 5, 3 and 17. So that is a 5, 3 and 17. So now we have to multiply these two matrices. So let us multiply. So now this is equal to, you know how to multiply like this. So this A1 one entry we do. So here you have to multiply with this 3 entry. This multiply with this one. Then addition. This multiply with this one. Addition. This multiply with this one. Yeah, first row and first column. First row, first row, first column. So minus 40 into 5. So minus 200. 16 into 3 plus 48. And then 9 into 17. So that is nothing but 153. Okay. Now second row and this column. So 13 into 5. So 13 into 5 equal to 65. Then minus 5 into 3, minus 15. Then minus 3 into 17, minus 51. Now third row and this column. So 5 into 5, 25. Minus 2 into 3, minus 6. Minus 1 into 17, minus 17. And so this is equal to, now 153 plus 48. So 153 plus 48 is equal to 201 and minus 200. So this is 1. Then 65, then minus 15, that is 50. 50 minus 51, so it is minus 1. Then 25 minus 6 equal to 19. 19 minus 17, so it is 2. So we have the answer as, this side is x1, x2, x3. So therefore x1 equal to 1, x2 equal to minus 1, x3 equal to 2. Okay. Next we'll take the in next video question.